if A and B are two numbers or quantities, and B is non-zero, then the ratio of A to B is A over B, like that. Why do you say they add this part right there?
Because if you're trying to divide something by zero,
Yeah, if you divide by zero, it messes things up. But yeah, a ratio is basically comparing two things using division. And the thing about this is we do it all the time. I don't know if you guys realize this or not, but any runners out there, you're often looking at your miles per minute, or minutes per mile is probably a more common thing, but minutes per mile, that's a ratio. That's comparing two things, the number of minutes and the number of miles. So and also, like, does anybody help their mom and dad shop at the grocery store a little bit? If you want to know what the best price is, you want to look at like a unit price. And what that involves is comparing the total cost versus the number of ounces or the number of pounds. And if you simplify that, you'll find the cost per pound or the cost per ounce. And then you can compare and see which things are a better price. Well, notice please, with division, order matters. So if they say a ratio of A to B, you want to write it as A over B. Also, you can write these as A ... or colon B. Those are some ways to write it as well. It says that, definition here, it says a ratio is the quotient of two quantities with the same units. I don't like that definition, and I would rather it just say a ratio is the quotient of two quantities. Now, the reason I say that is because I just gave you a bunch of examples where the units were not the same. For example, minutes and miles. Those aren't the same measurements, are they? What they're getting at is if you have two distances, you should, to get the ratio between them, if they're two distances, it's preferred that they're measured using the same units, okay? But this part is not actually part of the definition. And we'll talk about that more on example 2 here. But it says ratios are usually expressed in simplest form. Two ratios that have the same simplified form are called equivalent ratios. For example, 7 to 14 is equivalent to 1 to 2. Does that make sense to everybody? Mm-hmm. So what show of hands, is this review or is it new? Is it review? Okay, so for most of you it's review. All right, well it says simplify the following ratios. And notice in example 1, we're comparing yards to yards. So this might be that you're comparing the sides within a triangle, or maybe sides comparing two different triangles. But when you want to simplify a ratio, write it as a fraction, ensuring your order is correct. And then you want to make sure to simplify it. Since we do have the same units, what we could do is we could divide these units out and just say that the ratio is what if you simplify this?
13/16. I don't know. Or 13/6.
Yeah, I think 2 times 13 is 26, 2 times 6 is 12, the 2's divided out. You guys with me on that? Mm-hmm. So yeah, I think it's 13/6. So you can write your answer like that, or if you want to, you could write it as. You guys with me so far? Yeah. Well, 36 inches to 9 feet, I could totally write this ratio just using those units that they have there, 36 inches, 9 feet. And I could see, like, especially if we're like talking about a map, where the map is in inches, but the real units are in feet, we could have a ratio like this, and we could simplify it. How many times? Yeah, basically 4 inches for every what? 1 foot. And I think that's a totally legit way to do it. But you could also, they're saying, notice how I had to keep the units there? Well, thank you. bet. So notice, I kind of had to keep the units there, right? Because they're different. But if I was to rewrite 1 foot, what's the equivalent measurement in inches?
12 inches.
So if I was to write it as 4 inches to 12 feet, I could, I'm sorry, 12 inches, sorry about that. Then in that case, I could simplify this ratio down and say that it's 1 to 3. Okay, and they have different benefits. If we're talking about a map, you're gonna want this ratio. If you're just talking about pieces of lumber and you wanna know the ratio of the lengths between them, you could benefit from changing them to the same measurements and getting the ratio like so. So it's different applications. Well, and yeah, actually it's weird, my mind just blocks out those answers, it's funny. Okay. Now here's the thing, here's where people kind of struggle with ratios sometimes. Because ratios are simplified, if you're given a ratio of something, you gotta realize that that's not the measurements of it, it's just the ratio of it. So what I'm talking about is, on example 3, it says the area of a rectangular garden is 108 square feet. And the ratio of the length to the width is 4 to 3. I'm gonna need a picture to help me out here. There's usually a lively discussion in regards to whether or not this is length or width, and vice versa. It doesn't matter. So you can argue it either way, but it really doesn't matter. Just pick one to be one and one to be the other. So first off, it says our area is 108 square feet. So I imagine that's going to be helpful. Let's go ahead and read the rest of this. It says a rectangular garden is 108 square feet, area of it, and the ratio of the length to the width is 4 to 3. Find the length and the width of fence needed to enclose the garden. Now, when I first read this, I'm kind of thinking I might have to get perimeter, but I don't think so. It's actually just saying find the length and the width of the fence. So you can say that, maybe you say this is the length. I could also see how it can be the width, right? Doesn't matter. But go ahead and put the 4 with the side that you think is the length, and a 3 with the side that you think is the width. Well, here's the thing. This side is not 4 units long. This side is not 3 units long. So we're gonna have to figure this out. So talk about it for a little bit. See if there's a way that we can eventually find out what this length is and what this width is. And talk to your neighbor a little bit while I take a look.
Basically, if you multiply 4 times 3, you get 12, right? And then if you multiply 12 by 9, you get 108. So there you go. You got both sides. 12 and 9.
Okay. Is it 4 to 3, which means oh, okay. Yeah.
Shut up.
That only.
I got a 46. What did you get?
48.
Really? Yeah, that thing was wrong.
See, that's what I was.
We got killed in it in like 10 minutes.
I finished it. I heard
No,
that.
what?
Did you finish 12 times 9?
92%. Out of 50.
12 plus 12.
Yeah.
You
I was gonna say.
I think it's 40.
46%.
No, I agree with Brandon because
That was the hardest thing to take
the
on.
perimeter.
No doubt about it.
But I can go up to the side, like,
Oh, we're talking
talking
about
about
the area.
areas, bro. The areas.
Yeah, then it would be that.
Okay, so I heard a little bit of discussion,
I can't find my calculator.
but I think I heard Brandon, because I basically try to listen to everything Brandon has to say. I learn a lot. I really
I'm
do.
pretty good at this.
But So I heard Brandon say, I believe, and you can correct me if I'm wrong, Brandon, but you said, well, 4 times 3 is 12, which normally length times width would get you the area. But obviously 12 is painfully short, isn't it? But it's short by how much? Well, it turns out if you multiply 12 by 9, that'll get you there. So it turns out that the kind of like a conversion factor is 9, right? So another way to go about this is to say, and this is the way I'll present it, is we'll say that the relationship is 4 to 3, but these numbers are bigger, or they could be smaller depending on the situation, by some amount. Just like up here, when we had the real values and we simplified it, we actually divided both of them by 2. Well, to get back to the original, you would what? Multiply both of them by 2. So we're going to be multiplying these by some value, both of them, in order to get them to their actual lengths.
So 108 equals 4x times 3x.
So to get the area is equal to length times width, and we're told the area is 108 feet squared. So what is 4x times 3x?
12x squared.
12x squared.
And you get 9 feet.
And then how did you go about solving it?
Divide by 12.
Divided by 12. And
Is that 12 squared?
is that the 9?
Squared, but then you divide out the squares and you get 9 foot.
So are you guys familiar with how you undo squaring something?
Square root it, so x would equal 3.
Square root. And so the square rooting will undo this squaring. So our new units are, first off, it'll be 3, and then it'll be feet, won't it? So x is equal to 3 feet. And that means that our length here is going to be what? 9 feet. And our length here is going to be what?
12 foot.
12 feet. And I think we're good there. It kind of makes it sound like we need to get the area or the perimeter, but I don't think so. So, let's see. Brandon, were you correct?
Yes.
Were you?
Yes.
Okay. Ethan?
How did you get x equals 3?
Because of square rooting to
Oh.
undo.
And you have square root and 9 as well.
I didn't look at that.
Oh, you're good, you're good, yeah.
Yeah, that's probably the more mathematical way to do it.
Yeah,
Compared to
but-
my weird thinking.
I thought you said you would end up multiplying both of these by 9.
No, that's what I said.
You
I literally
multiplied-
said
Oh, so
I multiplied 4 and 3 to get 12, and then multiply 12 by 9, which means you have the 12, which is the first part of your ratio, and the 9, which was your second part of the ratio.
Oh, okay.
And I just went based off of that.
Oh, okay.
That's also because I already knew the answer, so.
Oh, yeah, it was written there. Well, what do you guys think so far? So this idea of basically giving a variable to every component of the ratio and then writing out the relationship, this can be used in a lot of different ways. So in example 4, it says the measures of the angles of triangle RST are in the extended ratio of 2 to 3 to 4. So it turns out that you can write ratios comparing lots of things. And in this case, we've got 3 different things compared using a ratio. Well, let's be careful here. It says we're going to find the measures of the angles. So we're going to have to find the measures of each angle. But it says triangle RST are in the extended ratio of 2 to 3 to 4. We got to be careful here because that's telling us precisely which angle gets the appropriate component. Does that make sense?
Yeah.
So where does the 2 go?
R.
R. The 3 goes with S, and the 4 with T. And again, is 2, 3, and 4 the measure of each of these angles? No. the actual measure is gonna be some factor bigger, right?
2x plus 3x plus 4x
Or
plus
smaller.
180.
And then, what equation can we write there, Caleb, what'd you say?
2x plus 3x plus 4x equals 180.
2x plus 3x plus 4x equals 180. So there we're using some triangle knowledge. And combine those like terms.
9x equals 180.
Divide by 9.
X equals 180.
X equals 20. Now, did it tell us, I mean, X, we created X, right? They didn't tell us to solve for X. What do they actually want to know?
Angle measures.
Alright, so what's the measure of angle R gonna be?
40.
40 degrees. Angle X. 60 degrees.
And 80.
And 80 degrees. Alright, how's everybody feeling?
Tight.
Pretty neat.
It's Friday.
Not for me, I gotta do stuff over the weekend.
Do you?
The rest of it will work.
Get to the date.
Okay, well, next up, ladies and gentlemen, we're gonna talk about proportions. And I want you guys to add something here. It says when two ratios are set equal to each other, this is called proportion. I want you to know something. Let me see what I wanna say. Oh, yeah. I want you to write proportions are useful in solving many application problems. Now, the reason I want you to add that to your notes is because I've worked out quite a few ACT math tests, and I found that oftentimes my mind will think, okay, I'm gonna write like a typical equation. But then I find out, well, no, that's not gonna be a way to solve it. And then I always gotta remember, oh, it's a proportional relationship. If they're talking about how something is related to something as something else is related, proportions are gonna be the way to go. So just kind of keep this in mind. If you're solving a math problem, and typically a word problem, and you're thinking, gosh, this sure seems like there should be an easy equation for this, I want you to think about proportions. Proportions will probably be the way to get you there. To say a proportion, you say A is to B as C is to D. It's saying the relationship between A and B is the same as the relationship between C and D. Now this next part is, it's all true. This is all true. But you're not gonna be tested over it. And it's not, I don't consider it especially helpful. We're still gonna talk about it. It talks about how the numbers B and C are called the means of the proportion, and the numbers A and D are called the extremes. This is all true, but it's just not that helpful, okay? The reason they go on to describe this is because you can solve proportions by doing the means extremes property, which is just another fancy name for cross multiplying. Well, here's the thing, if you've had me for Algebra 1 honors, you've heard me say that I don't care for cross multiplying as well. These are all accurate math definitions or properties, but I don't want to burden you with having to know them, because there's another way to do these that is quite simple. So without further ado, let's look at example 5. Truth be told, you can solve example 5 without me telling you anything new. Because what are you trying to solve for? What do you need to undo in order to get x by itself?
Divide 27 by 3.
Multiply by 20.
So since x is being divided by 27, to undo that division, what can you do? If you multiply by 27, you're going to get x by itself. But Where it gets tricky is example 6. That's a little bit trickier, okay? So here's what I suggest. How many of you love it when a problem has fractions? I think most of you heard me, you're not just ignoring me, but none of your hands went up. Okay, so here's the thing. Let's get rid of the 27 by multiplying by 27 on both sides. Do you agree that that's legal?
Yes.
Well, you know what? We don't like fractions. Let's get rid of the 24 by multiplying by 24 on both sides. That is perfectly legal to do, right? It's the multiplication property of equality. But what happens is, those 24s divide out, these 27s divide out, and you're left with 27 times 8 is equal to x times 24. Now, if you were solving this on your own, you would probably simplify this right away, but I want to show you something. This is the means extreme property right here. This is cross multiplying right here. But all we used was basic algebra that we're already familiar with. Question?
For an easier problem like that, couldn't you just do 27 divided by 24 and then use that and multiply it by 8?
27 divided by 24, do that.
Yeah, well, you get 1.125, and then 8 times 1.125 is 9.
Yeah. It turns out with proportions, there's many ways to solve it. Yeah, what's up, Ethan?
Well, it would be 24 or 27 divided by 27 divided by 3. We'll get the answer, right?
27. Yeah, because you're seeing that there's a relationship between 24 and 8, which is multiplying by 3. And yeah, that'll get you there as well. And like I said, there's multiple ways to solve proportions, multiple ways. But the way I've started it here, we'll divide by 24, divide by 24. And can you guys help me out? What do you get for an answer? 9.
Yeah.
Interesting.
Yeah, is that what you guys get? Okay. So now look at example 6. There's a little bit more going on. In truth, you can rewrite proportions lots of different ways. But what will reliably work is to say, I'm going to get rid of the 4x here. What am I going to get rid of on the other side? The x plus 3. And now the 4x is here, divide out to make 1. The x plus 3's divide out to make 1. What are we going to have left with on the left-hand side?
4x plus 2.
8x. We'll go ahead and simplify it this time since we're a little more familiar. And what do you suppose that 5 is going to have to do? Distribute, and we'll get 5x plus 15. And is that something you can solve now?
Yeah.
Oh yeah. What'd you get?
X equals 5.
X equals 5.
It's pretty simple.
Yeah, I don't think it's that bad. Okay, so now here's an application problem that we can look at. Let's see, I guess, yeah, we'll review it together. As part of a science project, you need to estimate the number of blue spruce trees in a 50-acre forest. You count 36 trees in 3 acres, and notice that the trees seem to be evenly distributed. Estimate the total number of blue spruce trees in the forest. Well, this is a problem that you might look at and think, well, there could be an equation I could write, but you're going to have more luck if you think about this as a proportion. So notice that they give you a ratio, don't they?
36.
Yeah. 36 trees, and I'm going to keep the units with it because they're different, right? 36 trees for every 3 acres. Now, in truth, you could write that ratio a upside down if you wanted. But I'm just gonna write it the way they told it to me.
12 trees per acre and then just multiply that by 15.
So that's one way to do it. 12, so you divided it and got trees per acre and then multiplied by 50. Or you could also, well, I mean, you're gonna get there the same way, but you can also say, well, how many acres do we have total?
50.
50. Make sure to put that with the same, in the same spot as the 3. And we need to know how many trees. And so there are multiple ways to do this. You could simplify this and then multiply by 50. Or if you want to, you can multiply by both denominators. Or you could cross multiply, couldn't you? I'm getting 1,800. I think so. Equals 3 times question mark. And then divide by 3. And how many
600 trees.
blue spruce trees are there? You said 600? Does everybody agree with Caleb?
Yeah.
600? 600 blue spruce trees.
That sounds like a very interesting tree.
Kinda does.
The blue.
600 blue
Some
spruce
Dr. Seuss
trees.
type stuff.
What do you guys think? Still good? Yeah, still good? Okay, I think we got a little bit more time left on it. Surely we do.
Yeah.
Oh, yeah, we got time. Okay. Next up is something called geometric mean. Now, have you guys heard of geometric mean before?
Yes.
I mean, yes.
You have? No, okay, all right. Well, because I honestly didn't hear much about it. I think I did learn about it in geometry, but all they told me was this part. They said if 2 positive numbers, A and B, the geometric mean of 2 positive numbers, A and B, is the positive number X that satisfies this proportion. Okay, that's the way it was told to me, like that's the geometric mean. And I never understood, like, why? Why does it matter? Why is it helpful? But the reason it's helpful is because you can rewrite that using cross multiplication or multiplying by both denominators. You can end up writing it as x squared equals a times b. And you can in turn square root both sides, right? And get this right here. This right here is what I want you to remember. Because that right there is the actual useful thing. That's the useful thing right here. Have you guys heard of finding the average? Oh, you guys know how to find the average of things, right?
Yeah.
What do you do when you just find the average of things?
Add them all
Add
up.
them all up.
Add them all up.
Divide them by how many there are.
Divide by how many there are. That is the arithmetic or arithmetic average. But there's also a geometric average, which gets the average of numbers by using multiplication instead of addition. And here's the thing. The reason, another way to think of this is you took a square root because there were how many things? Turns out there was 2. Well, if you want to find the geometric mean of 3 things,
Cube root.
you're going to take the cube root of it. If you're going to, I know it's startling, isn't it? It's okay. And then if you're going to find the geometric mean of, I don't know, how far does the alphabet go?
26.
We don't want to go that far, do we?
Yes, you do.
But then
You can't even do it on the calculator, can you?
No, you can't.
Oh, yeah, you can. Okay, so, if you're gonna find the geometric mean of 6 numbers, what's your root gonna be? 6. Exactly.
I didn't do that on the calculator.
There's a button that says like, this. on some of your calculators. Other calculators, it just has like this.
I see it.
Yeah. So this is another way to find the average of numbers, but it's using multiplication instead of addition. That's a much more useful way of thinking of geometric mean than this right there. Okay, so if on example 8 it says find the geometric mean of 36 and 54, I don't want you to write anything like that. I want you to just say, oh, okay, so I'm getting the geometric mean, I multiply them together, and then because there's 2 of them, I take a square root.
44.1.
And you got 44.1.
Yeah.
So you rounded to the nearest what?
10.
10th, right? Yep, 44.1. Now, what's kind of interesting is you can compare this to the typical average that you find, the average mean. Typically, how do you find the average of things? You add them up and divide by 2. Well, what would the average be for that?
What is that, 18.47?
45.
Yeah, it turns out the normal average that we think of would be 45. So see how it's a little bit different?
Yeah.
Turns out that some data is better related to an arithmetic mean, the one that we're more used to, but other data that involves multiplication, typically you can do a geometric mean and get that as well. So, ladies and gentlemen, there's the practice for you.
So what I'm hearing is no proofs.
You heard
That's
correct.
what I'm hearing.
No, I got it. Shouldn't tell you this, but you will see more proofs, but
No.
it's gonna be a while and very few, yeah.
Okay, so
So
that's.
you're kind of through proofs for a bit, yep.
So, that's gross.
Pretty-